Good afternoon. Up till now, we have seen classification of gears. Now, we will start another basic point, that is terms used in gears. Therefore, whenever you will find gear, we are not knowing which part of the tooth or what is the name of the part of the tooth. Therefore, there are different terms or terminology in case of gear. Now you are observing the diagram. Now first of all, we will see definition of pitch circle. What is its definition? It is an imaginary circle which by pure rolling action would give the same motion as the actual gear. Now you are seeing the diagram of the gear. Here it has been shown that exactly at the middle one circle is there. That circle is known as pitch circle. Now when you will take gear in your hand, or suppose we will take gear in our hand, we cannot judge where is pitch circle, and that's why its definition is it is an imaginary circle which by pure rolling action would give the same motion as the actual gear. Now there are major four circles are there in case of gear. First is pitch circle. Now next is addendum circle. Addendum circle means what? The circle which is passing from the top of the tooth or top of the teeth and which is concentric with the pitch circle is known as addendum circle. Next is dedendum circle. The circle which is passing from the bottom of the teeth. See that this is the bottom of the teeth. This is known as dedendum circle and it is concentric with pitch circle. Concentric with pitch circle. Now another circle is there, that is nothing but base circle. Base circle is in between dedendum circle and pitch circle. Therefore, what is its definition? Base circle is the circle from which involute profile or profile of the gear tooth is generated. Means starting point of the profile of the gear tooth is nothing but base circle and it ends up to addendum circle. And base circle and dedendum circle is connected with fillet radius. That definition is there. Therefore, major there are four circles are there in the gear: addendum circle, pitch circle, base circle, and dedendum circle. Now here also in this diagram you are observing circular pitch. Suppose this is the point on the gear tooth. Therefore, what is the definition of circular pitch? It is the distance measured along the pitch circle from a point of one tooth to the corresponding point on the next tooth. This is known as circular pitch. Now, second definition, pitch circle diameter. It is the diameter of the pitch circle. The size of the gear is usually specified by the pitch circle diameter. It is also known as pitch diameter. Now, if we are saying that gear is having 200 mm diameter, therefore that 200 mm diameter is nothing but diameter of the pitch circle. Gear is usually specified by pitch circle diameter. Always remember. Now next definition is pitch point. It is a common point of contact between two pitch circles. That means when two gears are in contact with each other or they are in mesh with each other, then that point of contact is known as pitch point. Next is pitch surface. Next is pitch surface. Now to understand the definition of pitch surface, we will go to the next slide. Then you will understand. See that this is the two gear teeth are there. These different terms used in the gear. This is the pitch surface element. See that this is the pitch surface element. Therefore, what is the definition of pitch surface? It is the surface of the rolling discs which the meshing gears have replaced at the pitch circle. It is the surface of the rolling discs which the meshing gears have replaced at the pitch circle. That is nothing but pitch surface. Now another important definition is pressure angle or angle of obliquity. It is the angle between the common normal to two gear teeth at the point of contact and the common tangent at the pitch point. It is usually denoted by letter phi. The standard pressure angles are 14.5 degree and 20 degree. Now what is meant by common normal and common tangent? I will draw the separate figure here. Then you will understand. Now I will draw two gears meshing with each other. Suppose this is the pitch circle of one gear. Try to understand. This is the pitch circle of another gear. Now these two gears are in contact with this at one point. Therefore, this point is known as pitch point. Now these two pitch circles are there, means two gears are there. Now I will draw another circle inside the pitch circle. Therefore, whatever this another circle I have drawn, this is known as base circle. This is known as base circle, and this is known as pitch circle. This is known as pitch circle. This is also pitch circle. This is base circle. This is known as wheel. Bigger gear is known as wheel. Smaller gear is known as pinion. Now, what is the pressure angle? It is the angle between common normal to two gear teeth at the point of contact and common tangent at the pitch point. Therefore, first of all, I will draw common tangent. Now, this is the pitch point P. This is the pitch point P. If I will draw one horizontal line, try to understand it. Therefore, this horizontal line is known as common tangent. This horizontal line is known as common tangent. Which is passing through the pitch point. Therefore, what is meant by common normal? Common normal is nothing but it is the line which is tangential to the base circle. Therefore, I will draw one line which is tangential to base circle and which is passing through the pitch point. Try to understand. Therefore, whatever this line is there, this line is known as common normal. This line is known as common normal. Therefore, whatever this angle is there, angle between common tangent and common normal is known as pressure angle phi. Is known as pressure angle phi. There are two standard pressure angles, 14.5 degree and 20 degree. I think you may have understood what is meant by pressure angle. Now we will see definition one by one. Again, this is another diagram. You are observing the diagram. In the diagram, there are different terms: addendum, dedendum, phase width, addendum circle, top land, face, flank, pitch surface element, working depth, pitch circle, tooth thickness, tooth space, then root or dedendum circle, circular pitch, total depth, clearance, clearance or working depth circle. Therefore, all these definitions we are going to see one by one. Therefore, what is meant by addendum? Addendum. It is the radial distance of a tooth from the pitch circle to the top of the tooth. Now just see, this is the addendum. This is the pitch circle, and this is the addendum circle or top of the tooth. Now radial distance means what? If we will extend this line, it will pass through the center of the gear. The line which is passes through the center of the circle is known as radial line. Therefore, what is the definition of addendum? It is the radial distance from pitch circle to the top of the tooth. Similarly, dedendum. It is the radial distance of a tooth from the pitch circle to the bottom of the tooth. See that bottom of the tooth means dedendum circle. Bottom of the tooth means dedendum circle or root circle. Therefore, radial distance from pitch circle to the bottom of the tooth is known as dedendum. Now next is addendum circle. Next is addendum circle. Therefore, here you just see this circle is there which is passing from the top of the tooth. This addendum circle is written here. Therefore, it is the circle drawn through the top of the teeth and is concentric with the pitch circle. Similarly, dedendum circle. It is the circle drawn through the bottom of the teeth. It is also called root circle. See that this is the bottom of the teeth. Circle is drawn here. Therefore, this circle is known as root circle or dedendum circle. One formula is there. Root circle diameter is equal to pitch circle diameter into cos phi, where phi is the pressure angle. Now, next, circular pitch. See that here definition distance is there. It is the distance measured on the circumference of the pitch circle from a point of one tooth to the corresponding point on the next tooth. It is usually denoted by letter PC. Therefore, mathematically, circular pitch PC is equal to D divided by T, where D is equal to diameter of the pitch circle and T is equal to number of teeth on the wheel. A little consideration will show that the two gears will mesh together correctly if the two wheels have the same circular pitch. Therefore, see that we'll see circular pitch here. It is the distance measured along the circumference of the pitch circle from a point of 1 to. Suppose I will take this point to the corresponding point on the next two. Therefore, whatever this circular arc is there, this distance is known as circular pitch. And circular pitch PC is equal to D divided by T. Now next definition, diametral pitch. It is the ratio of number of teeth to the pitch circle diameter in millimeters. Therefore, it is denoted by letter PD. Therefore, mathematically, diametral pitch PD is equal to T divided by D, where T is equal to number of teeth and D is equal to pitch circle diameter. Next definition, module. It is the ratio of the pitch circle diameter in millimeters to the number of teeth. It is usually denoted by letter M. Therefore, mathematically, module M is equal to D divided by T. Next definition is clearance. Where is clearance? You just see in the diagram. This is the clearance. It is the radial distance from the top of the tooth to the bottom of the tooth in a meshing gear. A circle passing through the top of the meshing gear is known as clearance circle. Next is total depth. It is the radial distance between the addendum and the dedendum circles of a gear. It is equal to the sum of the addendum and dedendum. Now if you will see here, total depth, this distance is there, that is sum of addendum plus dedendum is equal to total depth. Now working depth. It is the radial distance from the addendum circle to the clearance circle. It is equal to the sum of the addendum of the two meshing gears. Therefore, here working depth, it has been shown. It is the radial distance from the addendum circle to the clearance circle, or working depth is equal to addition of addendum of the two gears. Now, next definition is tooth thickness. See that this is the tooth thickness, or here it has been shown tooth thickness. It is the width of the tooth measured along the pitch circle. Therefore, whatever this width is there along the pitch circle, width of the tooth, it is known as tooth thickness. Now, tooth space. It is the width of space between the two adjacent teeth measured along the pitch circle. Therefore, this is the space between the two gear teeth. Therefore, this space which is measured along the circumference of the pitch circle, that is known as tooth space. Now next is backlash. It is the difference between the tooth space and the tooth thickness as measured along the pitch circle. Theoretically, the backlash should be zero, but in actual practice, some backlash must be allowed to prevent jamming of the teeth due to tooth errors and thermal expansion. Next is face of the tooth. It is the surface of the gear tooth above the pitch surface. See that this is the face of the tooth. It is the surface of the gear tooth above the pitch surface. Similarly, flank of tooth. It is the surface of the gear tooth below the pitch surface. Flank of the tooth. It is the surface of the gear tooth below the pitch surface. Similarly, top land. This is the top land. It is the surface of the top of the tooth. See that top surface of the gear tooth is known as top land. Similarly, bottom land. Whatever this land is there or this surface is there at the bottom of the tooth, it is known as bottom land. Face width. It is the width of the gear tooth measured parallel to its axis. See that this is the face width. It is the width of the gear tooth measured parallel to its axis. Profile. It is the curve formed by the face and flank of the tooth. See that this curve is there. This is the curve formed by face and flank of the tooth. There are two types of gear tooth profile, involute profile and cycloidal profile. Up to 90 to 99% you will find everywhere involute gear tooth profile is used. Cycloidal profile is rarely used because in case of cycloidal profile there includes two curves, epicycloid and hypocycloid. Therefore, we have to manufacture two curves to manufacture cycloidal gear tooth. Therefore, its manufacturing is difficult. And in case of involute, only one single curve is there. We have to manufacture only one single curve. Therefore, its manufacturing is easy. That's why 99% you will find involute gear tooth, involute profile on the gear tooth. Similarly, there are advantages, disadvantages of involute gear tooth and cycloidal gear tooth. In case of involute gear tooth, center distance between the two gears we can change. Center distance means what? I will draw the two gears like this. Therefore, this is the center line of one gear, and this is the center line of another gear. Therefore, this distance between the two center lines is known as center distance, CD. Therefore, center distance between the two involute gears can be changed. Means you can pull this gear outward. You can pull this pinion outward. You can change the center distance in case of involute gear. But in case of cycloidal gear, we need to maintain exact center distance between the center lines of the two gears. Therefore, these are some advantages and disadvantages of involute and cycloidal gears. Now, we have seen that there are two types of pressure angle in case of involute gear. First is 14.5 degree and next is 20 degree. Therefore, depending upon the pressure angle, there are systems of involute gear tooth profile. Therefore, first system is known as 14.5 degree full depth involute system. Now, how to identify 14.5 degree? Now, these teeth are of rag gear. You are knowing gears are manufactured by using two methods, that is gear hobbing and gear shaping. In case of gear hobbing process, hop cutter is used, and in case of gear shaping process, rack cutter is used. Therefore, to identify that what is the angle, pressure angle for that gear tooth, if rack gear which is having teeth inclined at an angle of 14.5 degree with respect to vertical, then we can say that that gear is having 14.5 degree pressure angle. Therefore, if you will observe these dimensions, this m vertical distance from this horizontal line exactly at the center, it is known as pitch circle line of the rack gear. From pitch circle to the top of the teeth, it is known as addendum. Addendum is equal to one module. Pitch circle to the bottom of the teeth, it is this distance is known as dedendum. Dedendum is 1.157 times module. This distance is known as tooth space. Tooth space is 1.5708 times module, and this is known as tooth thickness, 1.5708 times module, and these teeth are inclined at an angle of 14.5 degree. This is the pressure angle, and this is the gear tooth, which is manufactured by using this rack cutter having 14.5 degree full depth in old system. Therefore, 14.5 degree full depth in old system, it consists of basic rack. For this system is composed of straight sides except for the fillet arcs. In this system, interference occurs when the number of teeth on the pinion is less than 23. This system is satisfactory when the number of teeth on the gears is large. If the number of teeth is small and if the gears are made by generating process, undercutting is unavoidable. Therefore, this is 14.5 degree full depth in volute. Now, if you will observe carefully, this distance is known as base distance at the base. Please understand carefully. Now 20-degree full depth in volute. 20-degree full depth in volute. Therefore, in case of 20-degree full depth in volute, teeth are inclined at an angle of 20 degree with respect to vertical. Addendum is 1 time module. Dedendum is 1.25 times module. This fillet radius is 0.4 times module. Tooth thickness, this is the tooth thickness and this is the tooth space, which is same, that is 1.570 times module. Now if you will see the difference between these two diagrams, in case of 20 degree full depth in volute, the width at the base is more. Just check. Suppose this distance is there. This distance is more as compared to distance in case of 14.5 degree at the base. Therefore, since in case of 20-degree full depth in volute, distance at the base is more. That's why 20-degree full depth in volute gear tooth is stronger as compared to 14.5 degrees. Similarly, you can check this distance also. This distance in case of 20-degree full depth in volute and this distance in case of 14.5 degree full depth. Therefore, since width at the base for 20-degree full depth in volute is more as compared to 14.5 degree, that's why you can say that 20-degree full depth in volute tooth is stronger as compared to 14.5 degree. Stronger means what? This 20-degree full depth in volute tooth will take more load as compared to 14.5 degree. Therefore, the 20-degree pressure angle system with full depth in volute teeth is widely used in practice. It is also recommended by the Bureau of Indian Standards. In this system, interference occurs when the minimum number on the teeth is less than 70. Now, increasing 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 the pressure angle improves the tooth strength but shortens the duration of contact. Decreasing pressure angle requires more number of teeth on the pinion to avoid undercutting. The 20-degree pressure angle is a good compromise for most of the power transmission as well as precision gearboxes. The 20-degree pressure angle system has the following advantages over the 14.5-degree pressure angle system. First, it reduces the risk of undercutting. Second, it reduces interference. Next, due to the increased pressure angle, the tooth becomes slightly broader at the tooth. This makes the tooth stronger and increases the load carrying capacity, which I have explained to you. It has greater length of contact. The main advantage of the 14.5-degree pressure angle system is its quietness of operation. Now, next is 20-degree stub involute system. Now, what is the difference between 20-degree stub involute and 20-degree full depth involute? If we'll see the diagram carefully, in case of 20-degree stub involute, addendum height is 0.8 times module. And if you will see, in case of 20-degree full depth involute, addendum height is 1 module and dedendum height is 1.25 times module. And in case of stub involute, addendum height is 0.8 times module, dedendum is 1 times module. That means in case of 20-degree stub involute system, addendum height is reduced. Why it is reduced or why stub tooth is there? You will find that whenever interference of the two gear will occur, at that time, to avoid the interference, we can increase the center distance. Means I will draw the diagram again here. Therefore, whatever this center distance is there, if interference will be there, then we can increase the center distance. That is, we will pull this gear one first gear outward, then second gear also outward to some extent. Therefore, the center distance will get increased. Another measure to avoid the interference is we can reduce the height of the addendum. What is earlier height of addendum? In case of 20-degree full depth, it is 1 times module. Therefore, if we will reduce the height of the addendum, therefore how to reduce the height of the addendum? We have to use gear grinding process. We have to grind the teeth of the gear so that height of the addendum will get reduced. That is up to 0.8 times module, 0.8 into module. Therefore, once that height of the addendum is decreased, interference will not occur. Therefore, that's why this type of tooth is known as stub tooth. This type of tooth is known as stub tooth because here addendum height is reduced by using gear grinding process. Therefore, 20-degree stub involved system, the gears in this system have shorter addendum and shorter dedendum. The interfering portion of the tooth, that is a part of the addendum, is thus removed by gear grinding process. Therefore, these teeth have still smaller interference. This also reduces the undercutting. In this system, the minimum number of teeth on the pinion to avoid interference is 14. Since the pinion is small, the drive becomes more compact. Stub teeth are stronger than full depth teeth because of the smaller moment arm of the bending force. Therefore, the stub system transmits very high load. Stub teeth results in lower production cost as less metal must be cut away. The main drawback of this system is that the contact ratio is reduced due to short addendum. Due to insufficient overlap, vibrations are likely to occur. Therefore, these are the some advantages and disadvantages of stub tooth involute system. Now next point, design considerations of the spur gears. Now our actual chapter has been started. Earlier we have seen the overall introduction of the gear. Now there are different design considerations for the gears. Now we are studying spur gear chapter. For all the gears, these points are there. First is power to be transmitted. That is how much power we want to transmit from one shaft to other shaft. Then next, speed of the driving gear, speed of the driven gear. That is how much velocity ratio or speed reduction ratio we want to achieve. And last is the center distance. Last is the center distance. Now we'll see gear tooth failures. We'll see gear tooth failures. After gear tooth failures, we will stop. Now, there are two types of gear tooth failure. First is breakage of the tooth due to force exerted on the tooth, and second is surface destruction. Therefore, we will see first surface destruction. In case of surface destruction, first is abrasive wear, second is corrosive wear, third is initial pitting, fourth is destructive pitting, fifth is scoring. Now, surface destruction, abrasive wear. Now, what is by abrasive wear? When two gears are in contact with each other, at that time, suppose foreign particle will come in between the two gear teeth. At that time, that foreign particle will scratch on the surface of the gear tooth. See that here, scratches are there, small scratches are there on this gear teeth. Small scratches or small dots you are observing, white dots. This is nothing but when that foreign particle is trapped between the two teeth, it will scratch against the surface of the gears, and resulting wear will be abrasive wear. Therefore, the tooth surface is scratched by foreign particles in the lubricant such as dirt, rust, and well spatter of metallic bodies or debris. This can be reduced by oil filter using high viscosity lubricants and surface hardness. Next is corrosive wear. This is the corrosion. Why corrosion takes place? All of us are knowing. Whenever there will not be any lubrication, and suppose gears are lying idle in the open atmosphere, then at that time oxygen is going to react with the material of the gear and corrosion will start. Oxygen will be also there and water will be also there. Whatever water will be there on the gear, and because of that corrosion of the gear takes place. Therefore, this is nothing but corrosive wear. Corrosion means what? Iron oxide is formed or oxides of metals are formed, and that oxides of metals is nothing but corrosion. Therefore, the corrosion of the tooth surface is caused by corrosive elements such as extreme pressure additives present in the lubricating oils and foreign materials due to external contamination. These elements attack the tooth surface, resulting in fine wear uniformly distributed over the entire surface. The corrosive wear can be controlled by complete enclosure of the gears, selecting proper additives, and replacing the gear at regular intervals of use. Therefore, this is nothing but corrosive wear. Next is surface destruction. What is meant by surface destruction? We have seen this gear tooth is there. This upper part is known as face, lower part is known as flank. Now this is known as pitting. Pit, pitting means what? Or pit. In Marathi it is called as khadda. Therefore, small pits will be there. The size of the pits will be smaller in case of initial pitting. See that these pits are there on the gear tooth surface. You are observing small pits on the gear tooth surface. Therefore, this is known as initial pitting. Therefore, what is meant by pitting? Initial pitting. It is a type of fatigue failure caused by repeated applications of stress cycles. Pitting phenomenon is of two types: initial pitting and destructive pitting. Initial or corrective pitting is a localized phenomenon characterized by small pits at high spots. Such high spots are progressively worn out and the load is redistributed. Initial pitting is caused by the errors in the tooth profile, surface irregularities, and misalignment. This can be controlled by precise machining of gears and their correct alignment so that the load is uniformly distributed across the full face width and the dynamic load is reduced. Now, next is known as destructive pitting. See that now, whatever these pits are there, they are of larger size. Pits means in Marathi it is known as खड्डा. आता हे जे तुम्ही बघता इथं हे जे खड्डे आहेत गिअर टूथ सरफेस वरती ह्यांची साईज काय आहे लार्जर आहे and that's why it is known as destructive pitting. See that here gear tooth surface is there. Size of the pits is larger as compared to the size of the pits in case of initial pitting, and that's why it's known as destructive pitting. Destructive pitting is a surface fatigue failure which occurs when the load on the gear tooth exceeds the surface endurance strength of the gear material. This type of failure is characterized by pits which continue to grow, resulting in complete destruction of the tooth surface. In some cases, this may even break the tooth permanently. This type of failure can be avoided by ensuring that wear strength of entire gear tooth is more than the sum of static and dynamic loads. The surface endurance strength is a function of the hardness and can be increased by improving surface hardness of the gear tooth surface by using an appropriate heat treatment process. Therefore, to avoid destructive pitting, we can use different heat treatment processes, that is case carburizing, case hardening or nitriding. These are the heat treatment processes which are used to harden the surfaces. Now next is scoring. See that this is the scoring. You are observing scratches on the gear tooth surface. You are observing scratches. See that this is the scoring. Therefore, what is the scoring? The oil film between the gear teeth may break down under excessive surface pressure, high sliding velocity, and inadequate supply of lubricant. This results in generation of excessive frictional heat and overheating of the contacting surfaces of gear teeth. This may lead to metal contact. Scoring is a stick slip phenomenon in which alternate welding and shearing takes place rapidly at the high spots. This increases the wear rate faster. Scoring can be controlled by selecting proper surface speed, surface pressure, and flow rate of lubricant to keep the temperature of contacting surfaces within permissible limits. The bulk temperature of lubricant can be reduced by providing fins on the gearbox, air cooling by a fan, or circulating cold water. Therefore, now we'll stop here. In next lecture, we'll see different points, that is gear materials, force analysis, beam strength, what is the standard proportion of face width. Thank you very much. Please enter your roll numbers in the chat box. Enter only one time so that there will not be any confusion. Thank you very much.